Hello and welcome to another video from our BeamTool tutorial video series. In this video, we want to show you how we can use point spread function simulation and quality map tools for designing a phase array-based inspection technique. In the previous videos, we introduced point spread function simulation and quality map tools and show you how they can be used for designing full matrix capture inspection technique. Here in this video, we want to show you that these tools are also available for a phase array beam set and can help us to assess mostly how well we can take advantage of focusing in phase array application and whether a focused phase array will give us enough image resolution for sizing and sensitivity that we are after, or for achieving those we need to move to full matrix capture inspection. For this example, we're going to show you a coverage of a single V weld in a flat piece. And the first step, we load a phase array probe. And in this case, I want to take advantage of the 7.5 megahertz 32 element probe. And then I load a wedge with 55-degree shear nominal. Then we go to the beam set. I choose a sectorial beam set. Since my bevel was 30 degree, the normal to that would be 60, and I want to stick to 10 degree before and after that. So I choose to start with 50 degree to 70. I choose my beam deviation to half a degree, and to take full advantage of my aperture, I'm going to go and choose 32 element aperture and show the element usage to indicate that all elements are being used to generating these beams. Now, obviously, because I want to cover this bevel in the second skip, I need to move my probe back so that by increased offset, I'm at the point that now all my bevel is fully covered. Now, in this case, I can go to the similar to phase array beam sets, I can go to quality maps like PA quality maps. But the important thing to notice here is that the simulation will run for different skips. So here, obviously, because our interest is the beams in the second skip, we need to choose second skip, and then we can run the simulation. When we run the simulation, BeamTool automatically render the maps on the box that cover all the beam extents in the second skip. When the map is rendered, we can choose also to put the beam overlay on top by clicking on show beams. Now here you notice that when we move our mouse on the bevel, at every spot we can read a sensitivity value, and also you can see a preview of that point spread function, which basically show you that if you have any point reflector at any point along this bevel, because it's an unfocused beam, it will be imaged as an elongated arc, which obviously then will lead to oversizing. To basically simulate that oversizing, we can go and choose, instead of sensitivity, you can choose vertical resolution. And now here, you can see the values that are around 7.5, 7.6, all the way to something around like 2 millimeter, 3 millimeter at the very bottom. So essentially what it means is that when we are along the bevel here, we can have up to 7 millimeter oversizing of an image of a hole or a small side rear hole, which theoretically needed to be 0, but we can at some points even size that to 7.5 millimeter, which is not surprising because we are not using a focus technique. But to improve this, what we can do is to take advantage of focusing. So the first thing we do before I go to that option, I just want to rename this beam set and indicate that it's unfocused. Now I'm going to add another technique here, another beam set, but I'm going to try to make sure it's exactly the same one, but this time I want to see how I can take advantage of focusing. So to be exact, the same beam set, I go from 50 degree to 70, my beam deviation to 0.5, and I use all 32 elements here. But now here, to take advantage of focusing, I can come to the option on the top and choose one of the three focuses, which is true depth focus would be focusing at a certain depth, projection focus would be at certain offset, and half path would be at the sound path that is the same for all beams. So if you choose half path here, the first thing you notice is that now you will see these purple points on each beam, which indicate where we want to do the focus. If I come to the focus length here and increase the focus length until I reach at the sweet spot, let's say something somewhere here, that essentially my focus points are more or less aligned with the bevel, some of them before, some of them after, but the focal area is kind of close to my bevel. Now that we have focusing, and just to show you again, all the elements are being used, now I can re-render the point respect function based quality maps. So let's say we go to vertical resolution, and here again we need to remember that we need to set the simulation to run on the second skip, because that's where we are interested, and then we can now run the simulation. And now what is happening is that in the background, BeamTool knows that we are using focusing, so that will be taking effect into simulation. And now what you notice is, and I want to show beams again on top, now what you notice is that the vertical resolution is much improved, and you can see that basically how the blob is now not elongated. But to see this directly, we can directly compare this beam set to an unfocused one. If I choose here to say compare, BeamTool asks which beam set you want to compare this to, and I can choose the unfocused one. And now what happens is BeamTool resimulate point respect function, and now we'll try to plot these together in the same range of palette so that we can directly compare these and have basically values on these that can directly comparable. We'll wait for the simulation to finish, and then we can explain the concept. So here I turn on this other one as well. And now what you notice is that when we compare these two techniques, you will notice that when we move along the bevel, you will notice that always the size is much smaller when we use focused. So it is basically like and that's the effect of focusing, because now we have a smaller beam, we size the indication much closer to its original size. So here, when we had something in the order of 7.5 millimeter oversizing when we use unfocused beam, we improve that to something around 1.7 millimeter oversizing, which is much better accuracy can achieve much accuracy in size. Also, we can look at the sensitivity difference as well. If I choose to sensitivity, now that the sensitivity in both cases are on the same palette, you kind of see that it shows you much higher sensitivity along the bevel when you use focus, and that shows in the palette that your palette is kind of saturated. Also, it shows that the sensitivity is more or less uniform when we go on the sides from the focus. So at this point, these simulation tools help us to know that we can really take advantage of focusing here to reach higher sensitivity and much higher accuracy in sizing. But then the next question is, how about we move to FMC? Do we gain anything from that? Because the general understanding is that we can get much better sizing and higher resolution if you use 2FMC. But this is not necessarily always true. We can again use these maps to assess that. Because ideally, if we don't have to use 2FMC, move to FMC, we prefer not to avoid its complications. So I can just remove the comparison here. And now let's rename this beam set to focused. And now we can add a FMC technique. So for our full matrix beam set, to be aligned, since we want to cover after skip, we can choose and transmit a TT pad to cover after skip, and on reception also a TT pad. So we have TT-TT pad, and I'm happy with the box. And now here in this point, we can go and say, let's look at a vertical resolution, and we can say start simulate. Now this is a simulation tool that you have seen before. Now in our area we have vertical resolution map, and again you notice that as you move along the bevel, now the vertical resolution is showing us sizing around 1.66, and in fact at the bottom it just drops to 5, so we don't have much of a good resolution at the bottom, but uniform resolution along the bevel. But is this really an improvement from focused phase array? It might be more uniform across, but along the bevel, is it really improvement? Let's take a look at the phase array vertical resolution again. So we see that again the values are more or less close to the FMC one. So 1.7, 1.8, again, and more uniform all the way through the root here, that the root is also 1.63. But in case of FMC beam set, we are slightly better, maybe one from 1.7, 1.6, but then also not much of a good resolution at the bottom. So what this essentially tells us is that when we use this probe and wedge and this offset, in fact, when we use focused phase array, we get much better results, or at least comparable result. So what it tells us is that it's not the case that necessarily always you need to move to FMC-TFM. And here, these quality maps and the point response function simulation concept actually helped us to assess that. So here, what it tells us is that if we stick with phase array but take a use of focusing, we can get most of the way to take advantage of sizing and sensitivity and avoid moving to full matrix capture, inspection, or techniques to avoid complications that come with it in terms of the volume of the data, training that we need from the text, and things like that. So just using the focusing here help us to basically have a much improved technique. So then our choice here would be a focused phase array sectorial for inspecting this well. I hope that you enjoyed this video and hope to see you in the next videos. Thank you.